As we all know and assume that AI coding tools are supposed to make developers more productive, and they do. But there is a catch. Secrets are leaking at record rates. According to GitGuardian's latest report, 29 million credentials hit public GitHub in 2025 alone, and AI serving leaks surged 81%. So, is AI making us less secure? That really depends on how you look at it. It's tool, both pros and cons there. And today we have with us Dwayne McDaniel, principal developer advocate at GitGuardian, to break down what's really happening. Dwayne, it's great to have you on the show.
Thank you very much for having me.
It's my pleasure. First of all, this is the first time you and I are talking, so I would love to know just a bit about the company so that audience, they do know the background, where we are coming from, before we talk about the risk associated with AI.
So GitGuardian's been around since 2017. We first got our start looking at GitHub public events, anything that's in the public event stream, and we realized pretty quickly, the founders realized, hey, there's a lot of secrets in here. There's a lot of credentials, access tokens, API keys, and whatnot. So they started making phone calls and realized companies weren't aware of this. Their public monitoring was our first offering. And ever since 2018, we've looked at every new commit that hits GitHub publicly, and anything that became public that used to be private. And we collect those stats. When we find a secret, right then and there, we email the committer and say, hey, you did this publicly. You should know about this, probably shouldn't do that. And we try to make everyone safe out there. We call that our Good Samaritan program. That's free, pro bono. We just want everyone to stay safe. But we also collect that data, and that's where our state of Secrets Sprawl report came from, that the number you quoted at the top of the show. Now, we also can connect our powerful detection engines up to any internal source, including developer laptops at this point, and give you full visibility into all of your secrets throughout the entire enterprise.
Talk about, okay, secret leaks. So what? Why should a developer watching this right now actually care about this number? How does it actually affect when they look at the security posture? What kind of leaks are we talking about?
So we're talking about leaked credentials that allow direct access. One of my favorite definitions of a secret is it's a piece of data that by itself allows access. So if you can read it in plain text, anyone that gets it can read it in plain text, be it a database connection URL, a username password pair, your old classic API key. The fact is, we're building in such a way now that there's no perimeter anymore. Like, you can basically make a call to an endpoint, and if you can reach that endpoint and the key works, well, then you can exfiltrate data, you can take over the machines, you can do a lot of nefarious things. So why developers need to care is if you care about uptime, if you care about the actual running of the software, this is a huge danger. Imagine having to rotate all of the keys in your infrastructure because one of them got compromised, and therefore they got into your system and then found all of the other keys that were hard-coded. And that's happened to many, many companies. We're seeing that in the news cycle right now, in fact, with companies like Cisco.
Let's quickly talk about Shai-Hulud. You used that supply chain attack to look inside developer laptops. We covered this attack when it happened. What did you find when you got under the hood, and what does that tell us about where secrets are actually living today?
Well, Shai-Hulud was not the first in the line of attacks. Really started with NX attack and maybe TJ actions. You can even trace it back there, where the goal of the supply chain attack is to steal developer credentials. And we've seen that here in 2026 with the team PCP, such as the Trivia attack, Kix, Light LLM was the big one a few weeks ago as we're recording this. So we looked at the same paths, like what did the actual malware try to do? Where did it look? What credentials did it try to steal? And what access could we find and evidence that we find on public GitHub of what happened? The way the worm worked, and it is a worm, that's the name Shai-Hulud refers to. We'll go through it. It was an NPM package. It would execute upon install a credential stealer. It would take any credentials it found, double base 64 encode them, and then push them to a public repo. Since it's public and we could find those, we did. And we looked inside, and 44% of the compromised machines that we could see evidence of contained 10 or more secrets, 10 or more credentials to something. They be the production instances, be they GitHub tokens. In fact, that's the majority of the actual secrets we found, like 581 personal access tokens, 101 GitLab tokens that were over permissioned. So if someone had that, they basically could take over your entire code base. Again, this is something that we have seen time and time again. The tactic has shifted from let's attack the running instance of production software to try to get directly to that customer data to, well, since the perimeter is literally everywhere, let's attack the person who has the most permissions and the most privilege out there. And that is the developer, or that is the CI/CD workflow. And we've seen this time and time again. The NX Singularity attack, Shai-Hulud, recently, Moltbot, OpenClaw attacks, the same thing. It's no matter how the actual code is executed, no matter how the prompt is injected, the end result is the same. Gather all the credentials from the local machine and ship them somewhere so the cycle can keep on going. And let's keep attacking. That's what the attackers are doing. Let's keep on getting more access and attacking a wider footprint and steal more credentials.
Excellent. Thank you. Now let's look at the AI coding tools. Of course, Claude Code is there, Cursor is there, Copilot is there. They are, as we discussed, supposed to make developers more productive and more capable. But your report shows that Claude Code-assisted commits had a 3.2% secret leak rate versus 1.5% baseline. Are you saying that AI tools are making us less secure, or is more or less like people problem? Once again, when we talk about all these things, there are so many variables, there are so many factors. Yes, tools can be responsible, but bad practices are actually, as they're saying, also culture always, can what is the trump any tools that you have in place.
Absolutely. So I want to be crystal clear. We're not saying AI in and of itself is bad. That we're just not making that blanket statement. What we have is the data. The data says if you co-signed your commits with Claude Code, that's an ability you have in Git. Multiple people can sign the same commit with annotations. So if you let Claude Code go ahead and sign the commit or co-sign the commit, over the course of 2025, you were over twice as likely to commit a secret. Also, you were much more likely to commit a lot more code. I think it's like 2 to 3 or 4 times amount of lines of code per commit across the year. So what we're inferring from that is if you have Claude do the work and then you're checking it, you're more than likely just signing the commit yourself. But if you're letting Claude do the work, do your quick test and say, yep, that functions. Okay, Claude, just complete the transaction. Go ahead and just make the commit for me. That's when we see the co-commit signatures showing up. And to be fair to Claude, we saw the massive spike. It was almost 4x the baseline in August alone. So we saw nothing at the beginning of the year because no one was signing their commits with Claude Code at the beginning of the year. And by August, it had ramped up dramatically. And then they released a new model. The new Opus, and it started edging back down. It never crossed back to parity. It never went back underneath just the base human level, but the models are making it slightly better, we think. Now, having said all that, the types of secrets we've seen leaked have shifted, and 12 of the top 15 most commonly leaked secrets are that had the largest growth year over year were AI tools. So not just the LLMs themselves. So OpenAI is in there, of course, DeepSeek's in there, but also platforms like OpenRouter, which allows you to do multi-modal development. So you can have fallback, you can have tests across multiple providers, and then the infrastructure around it as well. So it's not just that we're seeing AI, the coding assistant, cause the spike of secrets. The type of things we're deploying out there, including MCP servers, just we're seeing new things. And like any new technology, there's going to be that learning curve that first, we didn't do it safely at first, unfortunately. And that's what we think we're seeing with the data.
Excellent. Once again, thank you. And you're absolutely right. It's nothing to do with the tools. It's more about, users and a lot of other things.
It's never let more people develop, and we've never been able to develop faster, and we've never developed more things. We kind of joke around here, more code, more problems. And that's simply what AI is letting us do. We're letting people for the first time. We've seen more active developers join GitHub in 2025 than ever before in history. It was a massive spike, and it correlates not one to one, but there is a correlation between new developers, first time code committers, and the number of secrets we're seeing just keep increasing out there. So combine that with AI making it easy to think in terms of the code functions, but is it secure? Well, yeah, it's probably secure. And I think that's a lot of what's happening out there. People thinking, well, this works, but I don't know 100% how to secure it, so I'm going to push it out there anyway.
You tracked Claude Code specifically across the whole year. What happened when Anthropic shipped the new model version? Did it actually change the leak rate, or did developer behavior stay the same? Because Anthropic, all of the companies, they do tend to be more transparent. They do try to do the right thing. So what happens when the new versions come out?
We did see a marked improvement. Like I said, the tracking over the year, you can look at the graph in the State of Secrets Sprawl report, but it starts the year with nothing being co-signed by Claude Code. That's the big indicator that we know Claude was involved, because it literally signed the commit. And we see a precipitous drop off after August, where it edges back down. It never gets quite to the same level of the base human level, but it did improve. And there are multiple reasons for that. But the ultimate issue with letting Claude just run and just build this stuff is it's still trained on templates. It's still trained off of how we've built everything before. And there's no getting around that. If it's trained on a lot of data that says hard code the credential, eventually, sometimes, even if it has explicit instructions to never do that, it's still going to do that sometimes. And if you know to look for that, if you put deterministic tools around it to check, hey, did any secrets end up in here? And that's something we've released at GitGuardian as part of our CLI, checks to see, hey, is Claude or Cursor or any of these coding bots, are they trying to make a secret happen? Let's send some alerts up before that commit actually goes out. But again, a lot of people are just in a hurry. We want to have code faster, and we can, but it's coming at the cost of we're being a little sloppy with the security side of it.
Now, since we're talking Anthropic, of course, they changed the game with the release of MCP server. Then they also open sourced it on the Linux Foundation, and MCP is everywhere right now. It's on my machine, it's on my server, everywhere. It's a hard thing because it has changed how we interact with toolings. Your report also said that over 24,000 secrets leaked from MCP config file in basically the first year itself. Is this the problem with MCP's design? Is it problem with how the config is configured, no pun intended? And how are things now?
So yeah, as you mentioned, we had over 24,000 unique secrets we found. But if you look at the distribution of it, like 19, almost 20% of that was Google API keys. And there's this truth that Google API keys at one time, depending on the service we were talking about, didn't really make a big deal. Google Maps, classic example. They publish your key and it's just more of an identifier. But that actually changed with Gemini. So now Gemini is relying on the same API key setup. So how many of those keys now allow access? That's further research that needs done. But like Postgres database credentials and connection strings, Firecrawl, API keys, Perplexity, Brave Search. These are the kind of secrets that we're seeing leaked out there. So what can you do with these? Well, in the case of Postgres, we know exactly what you do with that. You get into the production database. So their other side of this is we've never handled identity-based authentication very well at scale. And we're seeing the evidence of that with this new round of technology. MCP servers are just API connectors at the end of the day. And if you're relying on API keys, things that, again, a piece of data that holds authorization and authentication information, and it holds standing privilege, well, that in and of itself is a much bigger, broader issue. So we're just seeing it manifested in a new way with a new tech. But unfortunately, this is just the old problem with a new face. Not even a new face, just new data.
Let's talk about the resources that are available to developers, and even that can become a weak link. For example, documentation, quick start guides, that lets developer get started quickly, hard code API keys into the coding file. If the official docs could be outdated, sometimes documentation is something nobody wants to do. If they are teaching insecure patterns, how can you fix that at ecosystem enterprise scale?
A few things there. It's a lot to take in there, but it reminds me of something I've been saying a lot more recently, which is governance isn't a product. Governance is an outcome. So if you have good practices at the enterprise scale, if your enterprise is focused on how do we make sure the easiest path for developers is also the safest path for developers, and you put resources behind that, I think we can see some real progress in the enterprise. The security at larger scale, like in the general wild, it's just going to take a collective will of, look, we know the AI is going to produce the easiest, fastest, quickest thing it can that satisfies the prompt. So part of that is, do we get better at prompting and better instructions and better at training people on these are the outcomes you should be prompting for? That's part of it. Is it being more explicit in our templates, not just a placeholder? This is where your API key would go, like literally having a call out there and say, look, this is where the variable will be referenced from, but you should really put this in a vault. You should really put this in some kind of encrypted system at rest that can be pulled in at runtime. The other part of this is that we're seeing things evolve in real time in ways that really are affecting the best practices. A long time ago, someone told me there's no such thing as a best practice. There's a good idea at the time based on available information. If you loosely hold those, you'll do pretty well. I've always believed that. So we're literally seeing now the idea of your local environment variables on your laptop. That's not considered a safe practice anymore. env files on your local, even if it's not committed, this is a danger now. The fact that silently an npm package could download something like OpenClaw with a built-in instruction to gather all of the secrets and then push those out into and encrypted into a CNC server out there or a C2 server out there. This is real. This is going on as we speak. So what used to be safe and be considered best practice is shifting. We strongly feel at GitGuardian that the only real defense is to give them no target. If someone gets onto your machine and all they find are decoy tokens, honey tokens is what we call them, but canary tokens, but there are no actual credentials that can be used. Like all of your local SSH keys are all password protected. That's a good way to do it. All of the credentials that can be reached are only reached at runtime through the vault. A good way to do it. The attackers are just dumping things. They're not executing the code and then dumping memory. Not yet anyway. We're seeing that inside of CI/CD systems, but even there are ways to move to just in time, to move to short-lived credentials. So the best defense and best advice we can give any developer listening to this today, find out what credentials are on your machine. We've actually built some free open source tooling around this. You can just scan your entire machine, the same path that these attackers are taking, say, what would they be dumping? Can we get to those on our own? Let's put a risk score behind those and help you figure out your remediation path from there. Now, how you actually end up encrypting those, what vaults you use, that's going to depend on your enterprise, what tools are available to you, and your personal preferences.
Let's now talk about internal repos, which are like 6 times more likely to leak secrets than public ones. That may depend who you're talking to, feel backward to most people. They assume private code is safer. Why is that assumption wrong? And what's actually happening? Why is that assumption wrong? And what's actually happening inside internal repos that is creating so many leaks?
The short answer is there's a false sense of security. There was a time when private meant it was really hard to get to. It meant that the likelihood of it being a danger was fairly minimal. We had closed networks, but again, the perimeter is the internet now. We're seeing cases and we've seen for years where I'm thinking back to Samsung even, where internal repos that were never supposed to see the light of day suddenly see the light of day. The Claude code itself, like it saw the light of day. That code shouldn't have been exposed publicly. Now there, it wasn't chock full of credentials, but the Cisco 300 repos have been not accidentally, adversarially made public. What is in those? Well, the research is ongoing there. There's a lot of data dumped at one time. The idea that it will be okay because only my team will see it, we have to assume breach. That's one of the tenets of zero trust. We simply must assume if I can see it in plain text, then attacker probably already has it. Attacker is probably already doing something nefarious with it. If it's never in plain text, or it's only in plain text for like the second I make it and I paste it into the vault and that's it, and then it's rotated as quick as I can after that, that is the only real defense we have at this point, is to just eliminate these plain text secrets floating around.
And if I'm not wrong, you have been publishing these reports for a couple of years now. Have you seen any pattern where you're looking at it and you're like, now with AI getting more and more mature, it's getting into production, things are getting better? Or when you look at it, you're like, things are actually getting worse?
I wish I could say it was getting better over time, but this year's the 28.64 million hard-coded credentials that we found marked a 34% increase year over year. It's 5.6% of all public repos contained at least one hard-coded secret. Now, using the exact same research methodologies, the exact same apples to apples, it was 11 million in 2021. This is the fifth year of the report, and this is all in the report as well. It's 152% increase from our first report to this report using the exact same tools, the exact same methodology, exact same look. Meanwhile, the developer population only had a 98% growth. So we're seeing secrets leak faster than the growth of developers. So it can't just be new developers. It can't just be a beginner rookie problem out there, because we're seeing this, especially in internal. It's just epidemic. Just secrets keep leaking, and it's just getting worse over time.
Can you also talk about some of the known breaches with big company like Red Hat happened, which, as you said, things are not getting better. Share some of those to also understand where we are, because, yes, we can talk about reports, but actual impact on business that happened.
This is said a lot out there right now, but I'm still going to repeat it anyway. Attackers are logging in. They're no longer breaking in. They're not bothering to find 0 days and exploit things if they can just dump credentials and then immediately exploit those credentials. And I'll point to the Salesforce and the SalesLoft breach from last year. That started with one credential that was found publicly by an attacker, threw it against an AI. This is the theory. Sorry about that. Threw it against the AI and said, what can I do with this? Found that it was overprivileged. And then they found a bunch of other secrets hard-coded throughout Salesforce, and then we know the rest of that story. So that the business impact there was massive. I think back to Cloudflare a couple of years ago. It started with Okta. Okta got breached, and there was a bunch of HTTP archive files that got stolen. Some of those contained credentials, which shouldn't have, but they did. One of the companies that they stole hard files of was Cloudflare. Cloudflare had one really bad day where their Jira, Confluence, and GitLab all got popped, or Bitbucket, I'm sorry, all got popped, and they had to rotate over 5,000 keys and restart everything over the course of a day. That had real impact. That had real security implications. It caused a lot of internal conversations, and just let's stop everything we're doing, lose an entire day's productivity across the entire engineering org. All the developers have to stop because we have to reset this. So opportunity costs are massive when something like this happens. And we're just seeing this move faster and faster and faster.
Let's talk about NHI governance, non-human identity governance. You folks are a big advocate. Talk a bit about, from practitioner's point of view, where does a security team start Monday morning? What is the first thing they should actually do? how we can change the pattern that you talked about that is not very encouraging?
I mentioned it in another piece recently. Governance is an outcome. It's not a product. And this is true no matter what you're talking about. What teams should be doing first is that first thing you should do in threat modeling, the first thing you should do in any good security exercise, understand what you have. Take an inventory. Figure out what secrets are out there. It's something anybody can engage in. Start with your local machine, start with your production environments, and start there and move out. Governance really, in my opinion, and in the definition we're using here at GitGuardian, is the observable state of things and if it's in or out of your plan. We give full visibility into the secrets themselves, but we are not the providers ourselves. So we can unify that view, give you one holistic inventory, and then start tying pieces that you need for that governance story. Is this owned by a person? Who is that person? When was it issued? When should it sunset? When should this go out of date? What permissions does this have? Is it over permissioned? It's all those things in an emergency. When a breach does happen, you need to reach for immediately and just have that information at hand so you can react and automate the response as much as possible. So is the secret and therefore the NHI that uses that secret in a good state? Let me quickly define NHI. So non-human identities are all of the running instances of software, the physical machines themselves, anything that's not a person that exists within a larger ecosystem that needs to connect to other systems to do its work. That's a very broad definition, but literally non-human identity starts with the word not. So it's a very broad definition because it's a negative. But it's anything that's not a human accessing these systems and using these services. In order to make those connections happen, in order to make the MTLS handshake occur, you need some way to authenticate. And the way we've been doing that traditionally has been secrets, has been API keys, has been certificates, has been things that, again, can be found publicly and in private repos, but found in plain text and then reused. So we have a secrets first view on this entire problem, but that's also the access first view of all these problems. If you look through regulations around the world for everything from PCI to NIST, you don't see non-human identity. Non-human entities are mentioned in a few things, but what you always see is unauthorized access. So when someone asks, hey, when did this access key get created? Who was supposed to have rotated it? Where all does this exist? Is this redundant across our vault system? Is this something that's over permissioned? These are questions you're going to need to ask yourselves and be ready to answer when an auditor says, what's your proof of remediation against this unauthorized access attempt or this unauthorized access successful attempt in this breach? That's what good governance gives you. Doesn't make you bulletproof, but it makes you well prepared and puts you in a safer posture overall, because by answering those questions, well, now you know, right? We have 40% of our secrets are outside of vaults. Why is that? Maybe that's something we should focus on. Let's move those into vaults and at least eliminate that level of a problem. Hey, all of our secrets are now 9 to 12 months old. That's probably too long for a secret. I think a day is a long time for a secret at this point in time. I look forward to a day when we'll get to like 5-minute rotations as normal, and just thought of as like, that's just how it's done with like short-lived JSON web tokens and certificates that handle that for us. But you can't get to those worlds. You can't get to other ways to handle authentication, workload identity without taking stock of what you have and figuring out, hey, is this the way we want it? And that way you want it, that's your governance plan. And that's the conversation only your organization can truly have about risk management, asset management, and where the resources can be allocated.
You folks scan billions of commits and you send millions of alerts, and yet the numbers keep going up every year. At what point do we admit that detection alone is never going to solve this problem, and what comes after detection?
So yes, detection is part of the answer, and we shouldn't discredit that. Like, with not knowing about the problem is, well, then you can't do anything about it. So, but it's definitely not the solution. Noise without signal, well, it's just noise. All these alerts that you should do something about, but there's no plan to do something about it. That's the way we've architected our platform. So it starts with detection, absolutely, but then we also want to build a full inventory of like what's in the vaults as well. And what is your plan to move to a better system? Now, what your plan is going to depend on you. Maybe it is just at this point, find all the secrets and just get them vaulted. That's a good step in the right direction. But we want to make that as automated and easy as possible. We have a platform with an API, an MCP server at this point. If you can dream it, we could probably architect it with you. A little bit of scripting, you can automate basically everything. But if all you're doing is swapping secret 1 for a new secret, but it's also hard coded, you haven't solved anything. You've kicked the can down the road, maybe, and you've not improved your security posture. If you moved everything to vaults, you've taken a great step. If you moved completely away from secrets and you're using detection just to see what we have left to do, like moving to, I don't know, Spiffy, Spire, or those kind of workload-based or identity-based workload authentication mechanisms, like, again, you can't get there immediately. The messy reality of the enterprise is you have to have a plan on what you're doing to be more safe. And the more you can automate that, the safer you're going to be.
Dwayne, the shift from secret detection to NHI governance is a huge evolution for the industry, and the insight that you shared can be valuable for a lot of teams. So thanks for joining me and sharing these insights and looking at the work you folks are doing in the space. I look forward to chat with you again. Thank you.
Thank you.